Thank you very much, Stefan. Thank you very much to the colleagues and presidents and initiators from the other societies so that we can start the SFS and can start with the first seminar. It is entitled Sustainability Crisis in Scientific Societies. I have worded it as a dialogue between humankind in blue and planet Earth in red. I will start briefly with some emotions, go over to what you are probably more used to, only briefly 4 slides on climate crisis. Then I will explain a narrow survival window, go over to the broader aspect of sustainability, and if then Mother Earth has shown us her reactions, we consider what our achievements are, but also our deficits. And just about for the last third of the talk, I go into our options and our futures. I would like to acknowledge assistance with the slides by Patrick Breckner, Daniel Isaiah, and Alexander Frisch. Now, some of you may have had similar emotions. I start with 2022. The Yangtze River is the third largest river on Earth, and it dried up in large parts in summer of 2022. That was due to the fact because large parts of Central Asia had a heat wave for many weeks. That also meant that more of the glaciers in the Himalayas were melting, and some of the water came down the Central Valley in Pakistan. Combined with large rainfall, this meant that 33 million Pakistanis got displaced and left without drinking water. Now in 2022, these were 2 events related, different in space and different in time. Now for 2023, I just give you a glimpse of 1 week. Again, in different continents and in different nations. I will not say much. I mostly leave you alone for the next 25 seconds. Actually, this is just half of the video prepared by the United Nations Human Settlements Program. If you look at it, you can see the others also, but it doesn't seem to be much of a difference whether it's Guatemala, Oman, Turkey, Bulgaria, or somewhere else. Now, with these initial emotions, let us look at what Mother Earth tells us with the climate crisis. Some of it you may be familiar with. Now, with the climate crisis, about 70% comes from carbon dioxide. And as the argument goes, oh, well, carbon dioxide has been fluctuating all the time. And in fact, you can pretty much calculate it. It's related to the rotation and the tilt of the Earth. And it's quite fluctuating, and over 800,000 years. However, if you go a bit closer to current times, these fluctuations go way beyond the 260 ppm we had before, but they are rising, just with the annual seasonal fluctuations, and it's going on. Now, that has certain consequences. Here I showed you time. Now, go a little bit longer over time, look at average global temperature. As you may know, The average global temperature is now at 1.3 degrees C. This is global. Remember, over the seas it heats up less, over the earth it heats up more. For example, Germany is at 1.7. For example, the Arctic is higher. So certain parts are more. Now again, this has consequences. Now I go to a spatial regime. I go for the recent past and I go for the future in about 60 years' time. This is desertification over the globe. Red is bad desertification. That means it gets more and more difficult to do agriculture or even to live. Allow me to start in the West. So here we have in Mexico and Central America, we have the deserts widening. Spain, the Europeans know it's getting very hot. Recently it was 30 degrees. Here is Central Africa and some part in the south. You have heard about the fires in the east of Australia. And then there is some parts of China. Now, there are the simulations which have been tested over and over for decades, and you will see that Mexico and even up to Canada, the desertification will spread. Central Africa will have a broad band, South Africa will have. In Spain, you cannot do any agriculture anymore around the Mediterranean. The eastern part of Australia will be strongly affected. India and China will be hit heavily. Now, this is desertification. In summer, it is getting very hot and it is raining less. But in winter, it's raining more. So there's also an increased risk of flooding. Here, I don't give you the whole time domain, just a spatial domain. In South America, there's a strong increase of flooding. In the east of the United States, as well as in the west, in the central part of Africa. As far as Europe goes, of course, Netherlands, France, the United Kingdom will be affected. And again, in Australia, the eastern part, all of Southeast Asia, and India, and China, there will also be a strong effect of flood frequency. This means a return period of 100 years, and here this will be of 5 years. And of course, it will be bigger. So I thought I'll start with climate crisis because some of this you have seen, although maybe not all the consequences. Now, we actually have a rather narrow survival window. And I mean now, for today, one in carbon dioxide. I addressed this. I also told you about temperature, but there's also a narrow survival window in terms of time. I'll start with CO2. I have 2 slides each. The CO2 window, or in general, the window for greenhouse gases. Actually, it's not as long ago that the Northern Irish experimental physicist John Tyndall recognized the strong infrared absorption of gases like carbon dioxide. Svante Arrhenius, and the name should ring a bell with some of you, calculated the effect without computer. Granted, it took him a whole year. And he said, if we double the CO2 concentration in the atmosphere, Earth will heat up by 5 to 6 degrees C. He was not that bad in his calculation. Now, if we get rid of all CO2, the average temperature on Earth would drop to minus 21 degrees C. So we want quite some CO2. One must be amazed how we ever got into existence, but we don't want too much. In detail, for the 1.5 degree C scenario. Here is the clock by the Mercator Research Institute. 1.5 degree, we have another 230 gigatons left, will be met in 5 years, 5 months. That means in July 2029. The 2 degree C scenario will be met in 23 years, 2047. So the simulations have been going on and pretty well done for decades already. The temperature window is a little bit more involved. You may not be so fully aware of it. But you know that if we do a lot of sports, if we exercise a lot, we get warm. Because we are thermal engines with a power of about 100 watt. We cool through the skin. The higher the temperature, the higher the relative humidity, the more difficult the evaporation of our sweat, and hence the cooling. For example, at an air temperature of 46 degrees and a fairly moderate relative humidity of 50%, a person can survive for about 6 hours. You may say, no deal, there's nowhere 46 degrees. I have air conditioning anyway. But not everyone has air conditioning. And 46 in this, not so unusual, because such environmental conditions will be reached in Southeast Asia at the end of the century, but now almost annually in Calcutta. Now, the physics behind it is described by the wet bulb temperature. This is the lowest temperature that can be reached under current ambient conditions by the evaporation of water only. If we get exposed to a TW of 35 degrees for a few hours, this will cause death even in the fattest people under shaded, well-ventilated conditions. Now here is air temperature, here is relative humidity. That's a biosauna as comparison. And this here is 44 degrees, 55% relative. That was Murcia. That's a town in Spain that happened last year in August. And that happened in Calcutta for several days in April last year. And then these people, they will not be able to stay there for much longer, for much more many years, because they will have to run away. And they will want to go someplace. There's also the time window. The time window, there are actually two effects. There's the time we have to change our infrastructure, but also there's the time because there are the tipping elements. Now, a tipping element is an element which, if the event happens, will be irreversible and it will be self-accelerating. That means once it sets in, it will set in and it will self-reinforce. For example, the glaciers are white, they reflect solar rays, so the ice doesn't heat up much. If the ice is molten, it's black, it absorbs much more, it will heat up much more. No way to grow ice back on it. And the same in the Arctic and in the Arctic. Now already at 1.5 to 2 degrees, and I showed you the clock before, the Greenland ice sheet collapse will happen, the West Antarctica ice sheet collapse will happen, and the Labrador-Ermine Seas convection will collapse. This is Greenland, this is Labrador. Now, if this sea current stops, and this is one of cold temperature, high oxygen content, all of this Atlantic will be strongly affected, having ramifications to all the other oceans. Now, if an element tips, it doesn't mean it will be finished tomorrow. It can take maybe 20, 30 years until all the ice is molten. But when this is happening, then you know that New York will disappear or other cities like Shanghai will disappear. Not immediately, but you pretty much can calculate when it will be. So these are just the most imminent, but there are others, local and global tipping points, and these will be the effect of just this. Now we go back to Mother Earth. Mother Earth says, actually, I provide much more than climate. What do you want? I provide biodiversity. I have fresh water and all of this. So we need to look further. We need to look into sustainability. Now, allow me to explain what I mean with sustainability. I go by the Brundtland Commission of the United Nations in 1987. Sustainability means fulfill the needs of the current generation without compromising the needs for the next generation. This is pretty straightforward. If you consider world regions, it would mean it entails fulfilling the needs of one region without compromising the needs of other regions. Because already, at least since we are able to do nuclear war, one nation is not alone anymore, but we are all together in the same boat. And for sustainability, even more. There is therefore a twofold justice gap in time and in region. Now, this problem has been worded through the planetary boundaries. Typically, 9 planetary boundaries are described. A publication last year in September said we have transgressed now already 6. Novel entities means microplastics. An average human citizen eats every week 5 grams of plastic, with fish or with other stuff. Climate change is CO2 concentration affecting radiative forcing. That's a term describing the energy balance for radiation on Earth. There's biosphere integrity. We have been losing a lot of biological species over the last decade. There's a change in land system. We are getting into more and more problems of fresh water. In Europe, Spain is affected most because practically everything which is grown needs irrigation. People need that. Industry needs that. And the tourism, the golf courses should be watered. And then there are the biogeochemical flows with phosphorus and nitrogen. Actually, these 3 are not a problem at the moment. In fact, I will come back to ozone later. Now, all these are interrelated. That makes it complicated. If we try to address one problem, we might run into even more problems with the other one. This is just picking 5 out of these 9 to make it tractable. And this is just an example explained in this very recent paper. Now, of course, it's not tractable for you. It's for you, this is just a lot of arrows, just as we write in publications. We put a lot of arrows, everyone works with everyone. To explain a little bit more, if we are concerned with climate change, we want to get more lithium for electrical cars from mining, and we want to get more biofuels. So we cut down more rainforest, and we get a land system change, and we destroy actually carbon sinks. In order to grow better soya and corn for biofuel, we fertilize. That gives biogeochemical flows and pollutes the fresh water. The climate change, of course, also means altered rainfall patterns. That means it's a systemic problem. It's not a simple problem. I come to systemic problem and simple problem later again. Now, I said there are several planetary boundaries. There's carbon dioxide, there's water, there's nitrogen, there's ocean acidification. And this is just, again, in time domain. And again, humankind does something, and planet Earth reacts. First, humankind. Over 1750 to 2010, in that case, primary energy use goes like this. Water use goes like this. Population goes like this. Now, planet Earth says, well, if you burn so much fuel, the carbon dioxide will go up. If you produce so much carbon dioxide and so much nitric acids, your ocean will get more sour. That will affect the coral reefs. That will affect the fishes. And this is the nitrogen to the coastal zone. Now, in this paper, there's mention of a year 1950. And just in this, like in this paper, I met a red bar at 1950. And the description is that at 1950, the slope changes rapidly. Well, here's about right. Maybe here it could be 1960. Well, maybe here is about right. Maybe here it could be a little bit later. In fact, humankind does something, and Mother Earth gives us a few years until she fully reacts. So maybe here it could be a bit later until it changes dramatically in some cases. Now, before I had read that paper, I didn't know that 1950 was a fateful year. I didn't know where it could come from. And there's a very simple explanation. This is the plot, real gross domestic product. Now, the gross domestic product is a monetary measure for the sum of products and services provided in one country in 1 year. And it strongly went up at 1950. Yeah, this is strange, isn't it? And it is related to the fact that even that term, gross domestic product, came only about in about the 1930s. And by 1950, most countries and governments had decided the increase of the gross domestic product is their key goal for governance. Whatever government you have, whatever political system you have, it is somewhat faulty. So there will always be groups of people who are disadvantaged. So either you change your system, which is not easy, or you just stuff more and more stuff into this box and say, even the disadvantaged will get some. So you just put more and more in. This now has led to a quantification of the country overshoot day. It sounds like a complicated term, but it's not really criticized the way it is done. And most agree on it. Now, a country overshoot day means that a certain country has sources on things provided by Mother Earth and can use this in a certain time frame. If it has used the annual resources by December 31, it is just sustainable. So it just works out. But if your country overshoot day comes before December 31, you are not sustainable, and you even can calculate the factor. So Qatar, it uses up its resources on February 10. So it uses up its country every time 8 times over. The USA, more than 4 times over. Norway and Netherlands, almost 4 times. Germany, about 3 times. China, 2 times. There are some other countries who not even twice use up their country. And in fact, India is sustainable. But India is still developing, and it should develop. And it should have at least the living standard of all of us. But we all cannot have the living standard of all of us because Mother Earth doesn't provide it. So, I mean, this was recognized. And in fact, it was recognized in the 60s, in the 70s. And the United Nations installed the Intergovernmental Panel on Climate Change 36 years ago. Got a Nobel Prize for it. That led to climate change conferences by the United Nations. I still remember the videos and the report in TV when the delegates were weeping 2015. Yes, we did it. All the countries commit themselves to 40% reductions. Yes, we did it. No, they didn't. Hardly any nation is on target. Details can be read very clearly by the UNEP. And with the Conference of the Parties last year in Dubai, UN General Secretary Guterres pushes for a phase out of fossil fuels. Of course, there's a lot of resistance. That means we have political networks. We knew long ago we need political networks throughout the whole world. And they have proven for 35 years now that their efforts are not enough. And now they're also getting fragile. The world unity seems to slowly break apart with wars in Ukraine and in the Gaza and in others. Here come the scientific networks in. The use of both sources and sinks rises in exponential fashion. The Earth's ability to provide resources and take up pollution is limited. That means the political network requires support from another international network. Apparently, we don't know what we are doing. Now, I mean, of course, you may say, I'm a scientist. I only know one network. I only know the scientific network. I was thinking who would be competing and who would be better suited. But a scientific network cuts across all nations. It cuts across all disciplines. We all have partners everywhere in the world. And we get along very well with each other. We need to communicate. Also, as outlined before, with this complicated pentagon, the sustainability gap poses a systemic problem. Therefore, we need climatologists, biologists, engineers, natural scientists, human sciences to mediate the socio-ecological transformation. As scientists, we are trained to think beyond narrow boundaries. We just need to do it. We are trained to do so. So we can build on some of our achievements as scientists, also as nations. But we have deficits as human beings. You may have realized this. And here I just have 3 slides. At first, the achievement as a scientist, I alerted you to the fact that I come about the ozone hole, because the ozone hole was the one of the 9 planetary boundaries which was not in danger. It was discovered in 1985. It leads to a drastically reduced protection from solar UV. And in 1987, the reason was found with an increased concentration of chlorine monoxide, with chemicals which just had come up a few years before, for refrigeration, for example. And this is incredible. 1987 it was found. 1987, the UNEP achieves a treaty to reduce the production of chemicals, causing the ozone hole. And in 2000, but you see, it's a big success, but it takes 13 years. And then the production of chlorofluorocarbons, that's the bad ones, fell to 100,000 tons from 1 million. Not to zero, and it took 13 years. And I know we now like to point to others. And it's their fault. But actually many make efforts. Texas, we think of oil producing, but it produces 26% of US wind power. It's the leader in solar power. But the transmission lines are insufficient and take 8 to 10 years to build. China puts in 80% of the annual worldwide offshore wind power. China makes huge efforts, but still has many coal power plants. So there is something to report. On the other hand, we are human beings. And we know we are sometimes a little bit difficult to understand. There are the barriers towards sustainability. The first points I've gotten from the book by Christian Berg. He has it in German and he has a similar one in English. So the obvious one, and actually the big one, is market failure. This is called externalization of costs. In the production process, there are costs involved. If we buy a cheap T-shirt, there's some coloring agent. So we pollute the river and the government has to clean it up. But if you buy a T-shirt, you don't pay for what the government has to clean up later. These costs are not included. Whenever we produce something and we destroy the environment, we don't pay for it. Our children pay for it. There's missing international governance and legal problems. International waters are not protected. And if you look at human beings, I like this one. It's called acceleration in near-term decisions, and the catchy term is positive time preference. This is my favorite. We are such that we act with positive time preference because we prefer to have something good soon, even if it means something bad later. If we get a steak every day, we rather have 2 today and none tomorrow. Or we rather live well and our children don't live well. Consumerism, United States citizens shop for a new piece of clothing every 6 days. Now this I found, and this is media. In August 1986, this was the cover of the Spiegel, which is a big political magazine in Germany. It shows the Cologne Dome completely in water. And supposedly the Rhine flooded, that the dome is completely underwater. But even if the Rhine water has the highest level, it's still another 18 meters until the dome. Plus, there's the whole Rhine Valley, which it will flood first because the dome is high up. And there will never be like that. But if you, as a newspaper reader, have seen this in 1986, I can tell you whatever, because I've seen it 40 years ago, which was completely false, what media does to us. Actually, Christian Berg is much better in explaining the barriers because he's the vice president of the German section of the Club of Rome. He's an advisor to the national government, and he is a consultant to industry. So he understands much better. So I go on from here, and he can explain beautifully many examples. Now I come to the third part, our options, our future. Dennis Meadows, the author of Limits of Growth, said in an interview in 2022, Earth can support 2 billion people, but not 8 billion. Now, let's look up to 2050 and 2100. And let's look at how the temperature will evolve. because thousands of scientists have been trained for decades to predict it, and they can predict it. However, they assume different scenarios, and 180 nations of the United Nations have to agree. So Qatar will not agree with this line, and Saudi Arabia not. So they get their line down here, and it also gets it published. So there's a wide range. So, I mean, IPCC, this is the leading body we should go by, and we don't know what it says. So I took another authority. I took ExxonMobil, which is published here. ExxonMobil has been predicted a global temperature rise since 1973. And he has top scientists. And this is what ExxonMobil wrote. It's right in the center of all these lines. ExxonMobil says 2050, we are at 2.1 degrees C, 2100, we are at 3.2. If we go on like that. This is what ExxonMobil says, if you don't believe the IPCC. So, in 2050, therefore, climate zones will have moved towards the poles by 200 kilometers, up in altitude by 200. If we compare in Europe, London with Barcelona, so certainly in 2019 and 2023 and 4, the weather in London is quite different than Barcelona. But in 2050, the weather in London will be like in Barcelona today. So even in London, it will be very hot in 2050. By the same token, Seattle and San Francisco have quite different weather. But in 2050, this Golden Gate is the Space Needle. The weather in Seattle is like in San Francisco today. Now, financial losses. Some people don't believe in science, they believe in money. They believe in big companies. Let's look at money. The industrialized countries are using up their capital resources to reduce the impact of the sustainability gap. Now, that's an example from Germany, if I may. In 2021, the River R flooded, and the costs to get rid of the damage and to build up again was 40 billion euros. Now, even the Germans didn't know what that is, the River R, because it's a very small river. So even if that small river brings in costs of 40 billion euro, that may be a problem. The expected loss in Germany until 2050, 280 to 900 billion euro. So if we don't want these costs, we could do something, and then we don't have to pay for the financial losses. Then comes losses and needs. So if we have all these costs to get rid of our damage, we fall behind in our measures to move to green energy, enhance public transport, adaptation, and thermal insulation. Now here, I looked at what Swiss Re and Goldman Sachs say. Swiss Re is the second biggest worldwide reinsurance company. Goldman Sachs is one of the biggest in investment banking in the US. They say if the Paris Agreement is met by 2050, the losses per year are 4% in GDP. There's still a lot of money. If we have no mitigation, if we go on like now, we will be at 3.2 degrees and we will have 18%. In particular, for the 3.2 degrees C scenario, China is hit the worst. It has more than what the world suffers. US and Europe, a little bit less. Now, what is needed? And actually, companies know, they consult, they know this is needed. This is the big report by McKinsey 2 years ago. They calculated what do we need if we want a net zero transition by 2050. And all CO2 and methane, that's the other big greenhouse gas. Emissions today come from 7 energy and land use systems. Now, white is carbon dioxide, gray is methane. Power is about the biggest emitter of carbon dioxide. Industry similar, mobility a little bit less, forestry also some, buildings little. Industry and agriculture and waste are the big ones for methane. Now, this analysis included 69 countries, 95% of GDP. And the statement is the capital spending worldwide on physical assets nowadays for energy and land use is 5.7 trillion per year. It needs to rise by 3.5 trillion to reach net zero by 2050. This is about equivalent to half of global corporate benefits or 7% of household spending. To give you an idea, because I don't know what $1 trillion is, but this one I understand. If we compare this with the expected losses on the page before, this is like if the Paris Agreement is met, and 5 times higher if no mitigation is met. Of course, this gap increases with time. The more we wait, the more we have to invest, the less time we have. Now let's look in detail. This is CO2 and this is methane. CO2 has 40 gigatons per year. Methane has about 400 million tons. So this is 100 times more in tonnage, but this is 30 times worse. So it means the net effect is that this is about 3 times as problematic than this. Now CO2, the big one is power and industry. Now apparently with power, the chances are that we get to net zero quicker. Here is power, and it takes longer with mobility and with buildings. And here they actually say we need some removal, otherwise we never get to zero. This is methane. Methane, agriculture, you don't get rid of it. We will always heat up with the agriculture we do, and that is energy. Now, the argument is we are so rich, we have jobs, we need our jobs. These are the total job shifts by 2050. Agriculture job gains, auto small losses, power gains, hydrogen gains, oil, gas, coal losses, other gains, capital investment. Net, we gain 10 million jobs. We have more to do. Of course, we have more to do. We will have more jobs, but these will be different jobs. So now I come back to the role of the academics and of the scientists. I'm 4 minutes behind schedule. Now, the academics are a link between sciences, industry, and politics. For example, the German academics recently, that means a year ago, published a list of options for industry, society, and government towards sustainable development. I will not read all, but the first one means that the German academics altogether said the demand for energy must be lowered. That is like saying technology alone will not save us. And if the German engineers and scientists say we will not save you, then we all must save us. I come to universities. We must reduce energy consumption, become carbon neutral. We must be role model. We must educate students on the climate crisis. Here is an example by EPFL. Please put into whatever machine you want to use, EPFL sustainability strategy. It's really very good. So similar policies we need at other universities. And scientists and their international networks need to go ahead and need to give the impetus. Now I come to the scientific societies again. And we have done it before. The German Physical Society in 1986 warned of an impending worldwide climate crisis. The president of the German Physical Society was in national TV. Before, only Boris Becker was allowed to go on national TV and win Wimbledon. And then the president of the German Physical Society. And it had impact on the German government. But they were too early. The political networks thus have failed us massively in the last decades. And they come under increased stress. We need to learn from other societies. Here's an example of IEEE. IEEE is the biggest scientific society in the world with 400,000 members. And more than half of their divisions decided they need green meetings, waste prevention, eco-friendly travel options. This is what IEEE said. So, the aforementioned Alliance of Societies for a Sustainable Future. This is the goal. Today, we are actually starting with a webinar series with speakers from the current societies and beyond. We hope to include sustainable systems into the main conference. We are just starting beyond the narrow scientific aspect. We need to work to get our operations, conferences, administration more sustainable. We need to recommend outlines for teaching sustainability in universities. We need outreach to schools in general. And there are many of us. And there will be more of us. And we need to establish the alliance, and then we need to reach out across disciplines and nations. I'm slowly coming to the end. I'm at 45 minutes, 34 seconds. I started with some shocker. Allow me to start with a piece of dark humor. I hope you can stand it. Now, of course, people talk and of course, planets talk. Two planets meet. Says one to the other, "You look sick. Do you have a fever?" "I have Homo sapiens." "Don't worry, it will pass." This is the summary. Please consider to wake up. Technological solutions will simply not do. We have transgressed several planetary boundaries by a large margin. The required socio-ecological transformation is demanding, but is described by the big companies. It will pay off financially, with jobs, with a livable earth. But the truth is inconvenient. We have a positive time preference. It is much more convenient to close your own eyes and point to others. But others are not worse than us. I want to thank for encouragement and assistance by several advisory groups in Darmstadt International in societies I have. And I have a list of recommended books and reports, questions, comments, complaints, requests for PDF. Please under this email. 2 minutes late. Thank you very much.